All right, welcome America, India, and Selena Gomez. Today we are going to find the area of a sector, which is the area of part of a circle. And then we're going to find part of the circumference, which is, and the length of the arc that has the following central angle. Okay, so we're going to find part of the area and part of the circumference. So we already did this one problem. You can take a look at it if you'd like. Before we can start this problem, we see number 19, the problem we just did, gives us the radius and it gives us theta, the angle, in radians. This one gives it to us in degrees. So before we can start, we've got to change it to radians. So these are done, radians, love it, good to go. So now we go ahead and start. Oops. 1/2 radius squared times theta. We need theta in radians. So radians, or degrees, changing to radians. We're putting pi over 180 because using unit conversions from chemistry, we want the degrees to cancel and we want what's left over to be the radians. So if the degrees are already in the numerator, we need to put the degrees in the denominator so that those degrees will cancel. It's a lot more complicated in chemistry when you're doing those unit conversions. And you know, before I go, I'm just going to divide through by 10 because I think it's just easier. Okay, so now I've got 4 pi over 18, which is much easier to simplify to 2 pi over 9. All right, now I have my angle in radians, and so I'm ready to begin. So now I have numbers I can throw in here. 1/2, the radius squared is going to be 4, and my theta is 2 pi over 9. Now, this is 1/2 and 4. When I take half of 4, I get 2. So that's a 2 times 2 pi over 9. So that's just going to be 4 pi over 9. Good? Did you guys get that? Some of you guys did. Awesome. Okay. And the last one. Oh, radius. Radius is 2. Our angle is, what is it? 2 pi over 9. And we're actually going to get the same answer, 4 pi over 9, for the length of the arc. That doesn't always happen. Notice in this problem they're different. Area, length of the arc. And you've seen this, you've done this in geometry, it's been a couple years. But we do something similar with proportions to find these in geometry. And we don't use radians, we use degrees.